So let me introduce the speaker now. Dr. T. Rajani Garu is working as an assistant professor in the Department of Humanities and Sciences at VNRVJIET Institute of Engineering and Technology. She worked in various institutes with all academic and co-curricular responsibilities. Having 19 years of teaching experience, she has been actively involved in research since 2012 in nanoscience and technology. She attained her PhD in nanoscience and technology from JNTU Hyderabad and MSc Physics from Andhra University. Her research work is on synthesis and characterization of nanoferrite composites. Her research interests mainly focus on nano semiconductors, nanomaterials, nanoferrites, nanocomposites, and their properties. Involved in research projects, she published papers, books, book chapters in reputed international journals, and participated in various workshops, presented papers at various national, regional, international conferences. With this brief introduction, I invite Dr. T. Rajni Madam to come on to the dais and present her talk. Madam, please.
This column mic like this.
This one.
Okay. This is the point.
Have to go to the next slide then.
By using
Madam, name, say my business.
Sir, this one, right? Thank you, Dr. Any Suresh Kumar.
you can start now. Speak loudly.
Thank you, Dr. N. Suresh Kumar. Good morning, everyone. Today, I am here to give a talk on fabrication of nanomaterials by sol-gel and coprecipitation techniques. Before we proceed for the fabrication of nanomaterials, let us understand a brief view of different sizes of objects which we come across. Mainly, there are 3 different sizes. Fundamentally, all we know about 2 sizes, macroscopic and microscopic. So, macroscopic objects are usually seen with our naked eye. They can be directly measured in the lab. But microscopic objects require a special equipment which cannot be seen with our naked eye directly. It requires a kind of instruments like telescopes, microscopes to determine or to view the sizes. There is one more size which is next to the microscopic size, which is a nano size. Why this is treated as a nano size, first of all? Because the size of the particle is very, very lesser than the micron size. And also, these micro-sized particles can be seen with the help of light microscopes. But to see the nano-sized particles, we require electron microscopes. So, macroscopic not require any equipment. It is directly seen with our eyes. Microscopic requires light microscopes equipment, and nanoscopic materials requires electron microscopic materials. You can see here there is a range of scales is given where the nanomaterial or nanometer range is there. After that micro, after that macro. So this is the discrimination between the three objects. So what is a nanomaterial? The basic definition says that any material whose size is in the range of 1 to 100 nanometers. 1 to 100 nanometers. You can define that as a nanomaterial. You can see here I have given one scale where you have some cells, a kind of a bacterium, which is in the size of microns, and a hair fossil, which is in the size of microns, and the red blood cells. All of you are aware of the blood, right? So the red blood cells, which is in the size of microns. And as you are coming down, you can see the virus, which is a buzzword from the couple of years we are hearing, right? So it comes right from there, and coming to the proteins, which we have in our body, the DNA structure, which is there in our body, in every animal, in every plant, or in every human being, we have this kind of DNA structures, proteins. All these sizes comes under the nano range. Apart from that, the different materials, silver, you know about the silver articles, right? So usually in the olden days, people used to eat in the silver articles, silver thali, silver plates, silver cups. Why the silver is having more prominent? It is not indication of the rich, rather than the silver is an antibacterial. So eating in a silver thali boosts the immunity of a child and keeps you healthy. And sometimes maybe your grandparents, they can tell you there is a golden flower also there in the center for a silver plate. That gold nanoparticles are also used in the Ayurvedic medicine. So these particles, when you are taking it in nano range, they are becoming more stronger, more effective, more active, okay, and more reactive also. So that's why the virus has been multiplied 100 times. During the last couple of years, we have listened about the coronavirus, right? So there, the virus has been multiplied 100 times. Every day, it is becoming stronger. No immunity, although you take a lot of immunity boosters, you are not able to filter that virus. So because the lesser size, the more stronger, the more active it is becoming. So these nanomaterials nowadays, they are having so many applications in every day in every area. So some of the applications, major applications I have given here, you can see electronics, environmental, renewable energy, and textiles like hydrophilic are the two concepts where the textile industry is nowadays producing the shirts, the dresses, the clothes in such a way where if a cup of coffee also poured on your shirt, it will not be absorbed. There is no need to, there is no need to change another shirt, or there is no need to wash it. You can wear it, that kind of hydrophilic shirts. The textile industry nowadays is developing in that way. The healthcare industry is also one aspect where the drug delivery, if you are taking the cancer treatment, I think you have listened about these kind of diseases nowadays very frequently. The cancer treatment is one of the challenging area in the medical field. So to make a person to sustain from the cancer treatment. The treatment is done through the medicine is sent through the nanomaterial, which is tubular structures or a dot level structures. So that is in the drug delivery treatment, environment, renewable energy, electronics. I have given projected here some of the major areas where the advancement is seen. So like this, so many applications are there for these nanomaterials. So why small is good? You can observe in this diagram here, right from the bottom to the top. Here I have prepared a cluster of atoms. I have taken a cluster, or let us consider a cluster of atoms are arranged in 7 shells. When you are arranging in a 7 shells, whether it is a spherical or any way, you are having inside the spherical, inside the shell, 1450 atoms are there. And on the surface, 35% of the atoms are there on the surface. When you are arranging, there is a, like you have a notebook, you have a cover. The cover is taken as a surface. On the surface, 35% of atoms are there. In the same way, when you are taking a 5 shell of atoms, you are having 561 atoms you have arranged in these 5 shells. And on the surface, 45% of atoms are there. On the surface, 45%. In the same way, when you are going upward direction, I have decreased the number of shells, 3 shells. Then the total number of atoms which are there are only 147, and the surface area, surface atoms are 63%. 63%. And when you are going for a 1 shell, which consists of minimum of 13 atoms, 92% of the atoms are there on the surface. So from this, right from the bottom to the top, when we are going, you can say that surface area is increasing as the size is decreasing, which is one of the property of a nanomaterial, which while designing or while preparing, this should be achieved. This should be achieved. This is one of the criteria which is making the nanomaterials different from the macroscopic and also from the microscopic. So, because of this, surface area increases as size decreases. And why the nano objects we are preferring? One of the major reasons are they are faster, they are lighter. Since their size is very small, they can go into the small spaces very easily and can be very reactive and also active. And depending on the type of the product and the material, they can be available at a cheaper level, they can be prepared at a cheaper, low cost level, and more energy efficient and different properties. Like when you are taking material from the macroscopic range to the nanoscopic range, the properties, what are the properties which so far you have learned? The same properties, mechanical, strength-wise, size-wise, shape, color, electrical properties, chemical properties, magnetic properties. You name one property, I will tell you where it is changing. In that way, when a material is prepared at the nano range, it is more active. And you can see here, the 1 shell consists of only 13 atoms. Out of 13 atoms, 92% of the atoms are reactive. That means the surface is becoming more reactive, more active, actively participating in any kind of reactions. So that makes it more efficiently, more development at the level of the properties. So next, the other important aspect of the nanomaterial is quantum confinement. What happens is when you are taking any kind of material to this kind of nano range, the size of the atom or size of the particle is comparable to the wavelength of the electron. All of you know about the wavelength of the electron from the de Broglie hypothesis, from the quantum mechanics concepts. So, the wavelength of the electron. So the size of the particle is equivalent to the wavelength of the electron. So in that way, it is becoming. So the size, as the size is decreasing, more number of particles are participating very actively in the reaction. So for your understanding here, I have mentioned one diagram where everybody knows this as a conduction band and a valency band. And the band gap also you are aware that presents between the conduction band and valency band. So for a semiconductor, for a conductor, for an insulator, these band gaps vary. But when you are changing the size of the particles and study the band gaps, more cluster of atoms, innumerable number of atoms will be presenting in the conduction band as well as in the valency band, and the size will become narrow. It is not wide. The size will become narrow, confined width will be taking place when you are taking the material. So thereby the band gap increases. Band gap increases when you are taking the nanoparticle, when you are taking the band gap values of the nanomaterials. So you may have a doubt that the semiconductors are having the 0.5 electron volts band gap and insulators are having the greater than 5 electron volts band gap. If the band gap is increasing, will it be behaving as an insulator? No. The band gap is increasing in terms in such a way that it acts as a wide band gap semiconductors. Wide band gap semiconductors. So this is one of the aspects you can see. This is the concept which you have learned in the class, and here the band gaps are there. But as the size is decreasing, you can see how the width has been increased and it has become narrow. So there will be different energy levels are forming inside the conduction band and valency band at this level. And this property we name it as a quantum confinement. So this is one of the another property which should be maintained. Which is a important criteria to be considered for the preparation of nanomaterials. So these nanomaterials are divided into mainly three categories, but I have given a fourth one also here. So the first one is the one-dimension nanomaterials, two-dimension nanomaterials, three-dimension nanomaterials. So if you are taking one-dimension nanomaterials, although one side, one width, if it is in the nano range, we call it as a nanomaterial only. You are taking a cube over here and only along one direction. Length is in the nano range, breadth is in the other microscopic range, and width is also in the microscopic range. Then also we say it is a nanomaterial. It is a one-dimension nanomaterial. Similarly, if you are taking a two-dimension nanomaterial, either length or breadth or width or width or length, any two sides, if it is in the nano range, that is between the 1 to 100 nanometers, we say again it is a two-dimensional nanomaterial. If all the three sides are less than 100 nanometers, that is all the three sides are between the 0 to 100 nanometers, then we say that it is a three-dimensional nanomaterial. Apart from this, I would like to tell about this zero dimension, which I have put it as one dot. There is no dimension at all for these zero-dimension particles, zero-dimension nanoparticles. So usually we refer them as the size is between 0 to 10 nanometers. If you prepare any material and its size is in between 0 to 5 or 0 to 10, we treat them as a quantum dots. The best example is quantum dots. Using these quantum dots only, the medicine has been delivered inside the human body during any kind of treatment, especially during the cancer treatment. So, if you are taking the one-dimension particles, the thin films or layers. If you are taking the two-dimension nanoparticles, tubes, wires, and if you are taking the three-dimension nanoparticles, nano rings, nano shells, all these three comes under various types of nanoparticles, various dimensions of nanoparticles. So these nanomaterials, there is no need for us to prepare that in the lab. If you can observe them, there are some nanomaterials are there which are naturally occurring. So you can observe that naturally occurring nanomaterials are in the forest fires, sea sprays, mineral composites, volcanic ash. So in that way, you can observe those nanomaterials. And these are the different types of nanomaterials which are incidentally occurring during some works, For example, cooking smoke. Cooking smoke, during the cooking smoke also it consists of nanomaterials. Diesel exhaust, it consists of nanomaterials. Welding fuels, industrial wastage, industrial air effluents which are occurring in the air, they also comes under the nano range only. And these are all incidental because of the works which we are doing daily. So these are the different ways of nanomaterials. These are occurring due to the preparation, due to the experimentation which we do in our labs. So these are called as engineered nanoparticles. They are well defined. You can prepare in any kind of size, in any kind of shape. Either you take spherical, you will take cuboid, you take tetragonal, any kind of shapes, any kind of sizes you can prepare in the nano range. So the examples which comes under this human origin, the engineered materials which are prepared by our human, coming from the human origin are the metals, the quantum dots, the carbon nanotubes, the sunscreen pigments, and the nanocapsules. So these are some of the examples which I have mentioned here. So how to fabricate this nanostructures? Basically, there are two methods are there. One is a top-down approach. So top-down approach is like building something by starting from a larger component and carving away that component and to getting a desired shape. You can see we have considered a rock and you have carved it in such a way so that it can be having a beautiful sculpture form. And this top-down approach is you can prepare any kind of material by grinding or by washing, by filtering. So there are so many methods are there through which you can prepare. The other approach is bottom-up approach. So in this, what we do is we will build something by assembling at a smaller level. Like you take a brick by brick you assemble, you will get a building. Brick by brick you assemble like that, atom by atom you are assembling and you are getting a nanostructure. This is called as the bottom-up approach. And here also we start arranging by some procedures, by some techniques, and we will get the nanoparticles, we will get the synthesized nanoparticles over here. So before we go for the synthesis fabrication techniques, what are the important parameters one should consider? One should consider while the preparation of the nanomaterials. So here, the one is the time, temperature, pH. pH is the value which already you do, and frequency, pressure, concentration of materials, raw materials, whatever you are using, and the methods of synthesis, and the environment also. Environment also plays a very strong role while preparing this nanomaterials. So here, here the main important parameters out of them to do any kind of fabrication of nanomaterials at a lab level, at a normal lab level, the three important aspects which we should consider are the pH. The pH value should always be maintained for the material at a neutral level. All of you are aware of the pH, you have learned, right? So acidic, base, and neutral. So that pH value should be maintained. The solution value should be maintained. And the size of the material can also be controlled by using this pH value, by maintaining that pH value. And the second one is the temperature. The temperature, how much time you are using or how much time you are heating the material that temperature value also plays a key role over here. And apart from the temperature, the time and temperature are correlated to each other. If you want to maintain both time and temperature, sometimes you can keep one parameter as a constant and change the other parameter. And depending on that, you can change for which the reaction undergoes. And there are several methods. Lot of methods are there for the synthesis of these nanomaterials. But every method is having one or two setbacks. So depending on the non-toxicity of the materials, depending on the availability of the equipment, depending on the environment and the temperature factor to control, one can adapt any method to prepare these nanomaterials. So the basic here, we are mainly focusing on these three parameters: time, temperature, and pH. So there are different types of methods are available for the synthesis of nanoparticles. So one is the physical method, chemical method, biological method. So all these three methods are available. Through all these three methods, one can synthesize the material, any kind of material. And here you can make the material in the form of powder, in the form of films, in the form of solvents, in the form of liquid solutions. Any kind of state of matter you require, you can prepare in that way. Now, these are the different major synthesis techniques. A lot of synthesis techniques are available. So some of the major synthesis methods which are under physical methods are mechanical methods, vapor deposition, sputtering deposition, electric arc deposition, ion beam deposition, molecular beam epitaxy. Coming to the chemical methods, coprecipitation, molecular microemulsion method, solochemical method, hydrothermal synthesis, sol gel, and microwave synthesis. And biological method, you can use the plant extracts. You can you can use the aloe vera gel nowadays, and they are preparing reduced graphene oxide also. So like that, you can use the plant extracts, you can use the enzymes, and you can use the agricultural waste, and you can prepare the nanomaterials. Nowadays, our state government of Telangana also promoting these kind of research works across the institutes, and encouraging the students to participate in these kind of innovative ideas, so that the waste can be minimized, and you will get out of waste you will get a best product. Now, although there are several methods are available, there are some set drawbacks are there, some challenges are there while preparing these materials. So, the one for under physical methods, you have a lot of energy and time consuming. So you can use the physical method, but you have to have that product, that material preparation will take 24 hours, 48 hours, 72 hours sometimes. And the high temperature and high pressure should be maintained. Like you will work along with the 1200 degrees centigrade, 1500, and that maintenance is also mandatory. You should take the help of some person who is maintaining the equipment and done the synthesis of these materials. If you are taking the chemical methods, large scale production is not possible. But if you are taking a toxic chemicals while preparing the nanomaterials like lead, zirconium, so these are some of the elements which are available. But if you are started using those materials, it will be very difficult. Toxicity will be increased, and poison gases will be coming, so that it is very difficult for us to use the chemical methods if the toxicity of the chemicals is there. And if you are taking the purification is also one aspect in the chemical methods. Purification requires a lot of time. It takes a lot of time if filtration takes a lot of time, washing takes a lot of time in the chemical methods. So biological methods, you cannot control the size and shape. You cannot control the size and shape. And sometimes what happens after the preparation of the nanomaterials also, some kind of fungus can be, some kind of growth can be seen, other material growth, other crystal growths can be observed here. So, and moreover, it is a time consuming process. It is a time consuming process in the biological methods. But if we be able to control the toxicity, if we are able to control the time and temperature and pH, the chemical methods are the best one which you can take depending on the chemicals which you are efforting. It is a very simple, it is inexpensive, at a lesser cost, and the temperature is also, you can work at a lower temperature level. In this, I'm going to talk about the soldier method. So first of all, let us understand why the people are preferring, why the scientific community across the globe nowadays are preferring to adapt the soldier hydrothermal coprecipitation techniques. So in the soldier method, it is a very, as I told you, simple, economic, effective method. Homogeneity in the among the material can be maintained. It is depending on the chemicals which you are using. If they are if they are not toxic or non-toxic chemicals, then it is a friendly way of doing the experiment, and the purity of the product can be obtained. And at low temperatures, we can obtain a very good product. Also, you can get a different shape of the shape materials. Like means if you are preparing a nano material, you can observe there will be a tubular structure, there can be a spherical structure, there can be tetragonal, there can be flakes, there can be leaf structures, can also be obtained with this method. And there will be a strong bonding will also be observed among the atoms, among the molecules in the nanomaterial. Now, the major steps which are followed in the soldier method are sol formation, gel formation, viscous gel, drying, zero-gel, calcination, and heat treatment. So the majority of the steps I have given here. Any student, anyone who are interested, they can go through these major steps very easily. First of all, you take a precursor inside the beaker. Then you add the citric acid. Then you place it on the stirrer, set the temperature and stirring time, magnetic stirrer. Then you add the ammonium hydroxide, ammonia dropwise. Then after a certain time, you will obtain a gel, and this gel is placed in the autoclave or placed for a heat treatment for 5 hours or for 6 hours. These are the major steps. Apart from these are the generalized steps. But by following these simple steps, one can obtain the nanomaterial. See, this is the work which we have done. Taking the gallium nitride and ferrite. So here we have taken the gallium nitride and ferrite. We have taken a magnetic stirrer with a hot plate, and we have added the citric acid solution inside the materials. Both the gallium nitride is of different size, different color, white color. Ferrite is in the dark brown color. Both the materials are added up according to the ratio, and added the citric acid and kept it on the magnetic stirrer for 3 to 4 hours. And after adding the citric acid, we have added the ammonium hydroxide. The citric acid acts on the structural surface changes. It changes the surface of the material. And the ammonium hydroxide, why we are adding the ammonium hydroxide means the citric acid, since it is an acidic in nature, the pH will be between 0 to 6. And we are adding the base so that the pH value will be 7, which is a neutral value. And the second reason is the uniformity of the product, the homogeneity of the product is maintained. when we are taking the pH value to the 7. And then we have kept it under the heat treatment for 400 degrees centigrade for 5 hours. So I obtained a loose purple color powder where the color has been changed, which clearly indicates that the nano material has been formed. And these are the simple steps we have followed and prepared this nano material, gallium nitride ferrite. So gallium nitride is in white color, ferrite is in dark brown color, but due to this addition of citric acid, ammonium hydroxide, and stirring time, the homogeneity is maintained, the purity of the product is maintained, and we got the value of the sizes, the crystalline size value we come across 20 nanometers. So this is the second one, where the fourth BTech students, they have done under them as a major project by the Department of IEEE. So what they have done in a normal lab only, so they have added the materials, they took the citric acid, but here what the change is, the water, we have added the water in the initial, for the first experiment. Here we have taken the titanium dioxide and gallium nitride. So since it is not soluble in water, we have to do some kind of acid treatment. So after adding the citric acid, we have added the nitric acid also, so that the titanium dioxide will be easily dissolved in the acidic solution. By taking the pH meter also, we have tested the pH, but our students are interested in testing the pH with the pH paper, and they want to see how the color changes from the acid nature to the base nature. So they have tested here. And after stirring for certain time, we got the gel. And again, we have gone for the treatment. Furnace is used for the calcination purpose for nearly 4 to 5 hours. And this material is used as a one of the cathode or anode material for the rechargeable batteries. It comes under the mixing structures also. The scientific community nowadays working towards these mixing structures for rechargeable batteries applications. So this is the powder which we have obtained. Yes, these are the students which they have done. This is another material which was prepared by the mechanical engineering students, taking the titanium butoxide and the gallium nitride. The titanium butoxide easily dissolvable in water. So without much difficult, they have prepared this material under a minor project. And here you can observe the color of the powder is not changed. So there is no mandatory that each and every time whenever there is a nanomaterial prepared, the color should be changed. We have gone for the further testing, and the nanostate conformation was given by the characterization techniques. Now coming to the coprecipitation technique. Co-precipitation technique is also more or less similar to the sol gel technique. Here also low temperature, low cost, high yield, high purity is maintained. But also crystallized size is also sustained in this. But at the same time, there are several steps, more steps to be followed to prepare this material by co-precipitation technique. At the commercial level, at the lack of necessity to use the organic solvents, and the filtering, washing, drying the material. These are some of the general steps which one should follow to prepare the material by this technique. So here you can see mixing, stirring, aging for 24 hours. Time consuming is more for this co-precipitation technique. So as I have shown you, the students who has prepared these materials, nanomaterials, they took only 2 days time. Each day they have spent 6 hours, right from morning 9 o'clock to the evening 3 o'clock or 2 o'clock. Within 2 days, the material preparation is completed. But for this co-precipitation technique, if you are going for the aging, you have to keep the material for 24 hours for long duration. And then you have to wash it, you have to filter it. But no doubt, the larger level output is obtained. For example, if you are taking the sol-gel method, the powder or the liquid which you are preparing will be around some 5 grams or 8 grams. But using the co-precipitation technique, we can prepare a larger quantity of the nano powder. These are the some of the major steps which includes the co-precipitation technique, similar to precursor, but here there is no need to add the citric acid. There is no need to add the citric acid. You can directly adjust the pH by adding the sodium hydroxide solution or ammonium hydroxide solution. So there are the scientific community, the researchers nowadays they are preparing alkaline co-precipitation technique, acidic co-precipitation technique, depending on its application also. Or you can neutralize the material by taking the pH value to 7 also. Here, without the addition of the citric acid, because of the washing, filtering, and aging, it works on the surface area. So here, the citric acid step is not there in this co-precipitation method, and the precipitate is obtained. After precipitation is obtained, you have to filter it by using the filters which are available in the lab. Then you have to grind it. You have to dry, wash, grind it using normal grinder, and then you have to calcinate the material at a minimum temperature for 120 degrees centigrade or 250 degrees centigrade right from the minimum, or you can go for the 1100 degrees centigrade also. Usually, this co-precipitation technique is preferred to prepare the magnetic nanoparticles, which we use as the soft magnetic materials, hard magnetic materials. If there is any magnetic material you want to have in the final product, then we usually follow the method of this co-precipitation method. And a large quantity, large output is also obtained when compared to the sol-gel method. See, this is the one which we have done this work at JNU Hyderabad Center for Nanoscience and Technology. Here we have simply used the material, the nickel magnesium hydroxide, and then we have still the solution under the constant temperature maintaining at about 60 to 80 degrees centigrade. And then we have added the ammonium hydroxide solution to make the pH value to 7. We don't want to have a material which is alkaline in nature nor acidic in nature. We want a neutral material. So we have added the pH value, we added the ammonium hydroxide droplets. And after that, the precipitation was obtained and it was dried, washed and dried for nearly 8 to 12 hours. Then after it was dried in the hot air oven also for nearly for 12 hours. And then we have obtained this loose powder, which we have further used for the preparation of the capacitance materials. They have washed that and they have dried it and they got the carbon nanotube structure. So these are some of the conclusions. Type of the application, the material, equipment availability, time, temperature availability. One can adapt any of the two procedures. And if you are taking the co-precipitation techniques, you will add the as per the ratio. You are taking the precursors and you use the magnetic stirrer in both the cases. And here you don't add the citric acid. Here you will add the citric acid and adjust the pH to 7. And here the residue, after obtaining the residue in the sol-gel method, what we do, we directly go to the heating treatment. There is no need to wait at the room temperature. But here we have to stir it, but we have to stir it for the 5 to 6 hours. But here the stirring time can be decreased, but you have to dry it, wash it, filter it, the material with hot distilled water. The material or sample is grinded here. There is no need of grinding is required in the soldier. And calcinate the sample here also calcinate the sample. So this is about the differences between the two methods. Depending on the availability, one can work accordingly. Thank you.
Thank you, madam. Thank you, madam, for your nice presentation on nanomaterials preparation methods. Now the session is open for questions. Students, please ask any question. We invite questions from students first. Don't feel hesitate to ask any question. Please. Yes, please.
Good afternoon, ma'am. Good afternoon. I'm Gitanjali from ECD. My doubt is from the topic which you explained. Why small is D? Why is our discussion only confined to nanotechnology? Why are we not going into more micro details of it, like angstrom units or picometer units?
See, here the nanomaterials are in the range of 1 to 100 nanometers, 10 power minus 9 nanometers. Nowadays, the technology is based on nanotechnology. Means the materials which they are using by these materials only. So we are more confined to synthesize those materials and use them for the further applications.
Can we correlate to your second slide where you showed like one shell when you fill when
Yeah.
getting 13 atoms?
Yes.
So can we understand this in this way? Because one shell is the minimum basic requirement.
Yeah,
of
basic
an atom.
requirement.
So
Yes.
that's the reason why you are stopping with nanotechnology.
Like you consider 3 atoms are there or 10 atoms are there inside a spherical shell. Normal at the macroscopic level, if you want to react to that macroscopic spherical shell having the 10 atoms with any material, the reaction may not, the reaction will be happening at that level, macroscopic level also, but more atoms will not be participating in the reaction. But when the size is decreased, you are considering the size of the atoms is being decreased to such a level. The number of atoms which are at the surface are more in number. So reaction will be very intense when you are taking that nanomaterial into consideration. So the when you are doing any kind of reaction, hydrogen and oxygen or whatever, in a high, there are 10 atoms in the sample A and 10 atoms in the sample B at the macroscopic level. There is no mandatory that all the 20 atoms will be participating while doing the chemical reaction. But here, if you are preparing that A and B material at the nano range and do the same chemical reaction, the out of 10 atoms, 9 atoms in the sample A and 9 atoms of the sample B will be participating in the chemical reaction. So the output will be more efficient, the output will be more enhanced when compared to the macroscopic level. The participation will be increased. The participation of the electrons you consider, or atoms, or molecules, whatever you are considering, the participation of the atoms in every stage will be increased. More number will be increased. Small is good and more active. Small is good, small is stronger, small is active, small is more reactive, more proactive.
I think future can be expected to go to angstrom level or picometer level.
The size of the nanometer itself is 10 power minus 9 meters, right? So there is again a Zika technology is also there, which was developed in the Germany. So which is around 10 power minus 24. So the technology is advancing. It is there. It is already there. Some parts of the world.
And with your permission, you said that I were not going to be below classical length, okay? But there are some limitations in utilizing them for particular application and understanding them using the current technology. Okay? But people are trying that one. And I'm looking at them.
Yes, students, if there are any doubts, please ask.
My doubt is, ma'am, my doubt is, can we use this nanotechnology, these materials to eliminate the pollution in our environment?
Definitely we can use. Already it is there. To clean the water as a and the air, it was already there in the market. It is there. The technology is already available in the market. But
We also treat the
the air pollution, see, the air pollution, if you want to clear, it requires a special kind of filters, which you can use, like a mask, and you can filter the unnecessary elements to pass through your body. That kind of the filters availability is there, and it was developed by the IIT students only.
Dr. Vaishnav Madam is going to be here only. If you have further doubts, you can contact her, madam. She'll be in the Department of Information Sciences. So you can all actually contact any field faculty, okay, for any further doubts. I request Dr. Vishnu to conclude the session.
Thank you, sir. So let me summarize the whole session here. So here, in few words, so now we all actually understood the preparation methods of nanomaterials and their importance, and their electronic structure is different compared to the bulk materials. That is why they show different different properties, optical properties, thermal properties, and chemical properties. And then there are two approaches to synthesize the nanomaterials. Two approaches are there, top down and bottom up. And now there are various methods to synthesize these materials. Out of many methods, sol gel is the best method. That is highlighted, preferable method, I could say. And other than that, there is another method, coprecipitation method, which is involving, that method involves many steps compared to the sol gel method. And comparison of these two methods is also explained here. So with this brief summary, I thank Madam for giving the talk, and also I thank the organizers, Dr. Tribal Garu, for giving me a chance to create the session. Thank you, one and all.
Thank you, sir. Now you can leave for your lunch. Those who